All right, welcome back. This is video part 2 on patterns in mathematics, class 6, and this is where we ended. All right, so let us continue with the next question. So we ended on question number 7 on worksheet number 1 on patterns in mathematics. So let us continue. Question number 8, the sequence 1, 8, 27, 64, and so on are called dash numbers. These numbers here, 1, 8, 27, 64, are called cube numbers, are known as cube numbers. Why? Somebody can ask you a question. Why are these numbers 1, 8, 27, 64 are called cube numbers? What is the reason? They are called cube numbers because they represent the volume of a cube with side length n. For example, if you have a cube, I think everybody knows how a cube looks like. A cube looks like this. That is a cube. If, for example, from here to here is 1 unit, and here is 1 unit, and here is 1 unit, what is the volume of this cube? The volume will be 1 into 1 into 1. And what is this equal to? 1 into 1 into 1 equals to 1 unit cube. That means you have 1 cube present here. I will explain very nicely what do we mean by cubes and how do we sketch them. So 1 into 1 into 1 equals to 1. This is what we call the first cube number. So the first cube number is 1. How do we get 1? That is the same as 1 into 1 into 1, and we call it 1 to the power of 3. And that equals to 1. How about the second cube number, which is 8? How do we get it? Is 2 into 2 into 2, meaning 2 into 2 into 2, which equals 2 to the power of 3. And 2 into 2 into 2 gives you 8. And 8 is the second cube number. So you keep going. To get the third, you're going to do 3 into 3 into 3, which equals to 3 to the power of 3, which is equal to 27. Now, if they ask you a question, can you tell why are they called cube numbers? And can you draw a pictorial representation of maybe 1, 2, 3, 4 cube numbers, or even 5 cube numbers? So, why are these known cube numbers? Because they represent the volume of a cube with side length n, for example, 2 to the power of 3, 3 to the power of 3, and 1 to the power of 3, which equals 1. I will explain all this. 1 simply means 1 into 1 into 1, which equals to 1 to the power of 3, and this equals to 1. 8 is the same as 2 into 2 into 2, which equals to 2 to the power of 3, and this gives you 8. 64 is the same as Sorry, I skipped 27. So let me go back. 27. This 27 is the same as 3 into 3 into 3, which equals to the 3 to the power of 3, and this gives you 27. Now, these numbers here, 27, 8, 1, these are what we call cube numbers. Now, why are they called cube numbers? Everybody pay attention here. Why do we call them cube numbers? Reason. They are called cube numbers because they represent the volume of a cube with side length n. For example, 2 to the power of 3 will mean 2 into 2 into 2, which equals 8. 3 to the power of 3 will mean 3 into 3 into 3, which gives you 27. All right? Now, so why are they called cube numbers? The reason is too simple. They are called cube numbers because they represent the volume of a cube with side length n. This example and all this is not important. So just say, why are they called cube numbers? Is because they are called cube numbers because they represent the volume of a cube with side length n, right? So this is not that important in your level. But the reason why they are called cube numbers is because they represent the volume of a cube with side length n. Now, can you represent maybe the first 4 cube numbers, which are 1, 8, 27, 64? Can you represent them using pictures? Now, this is what I want everyone to pay attention. So how do we represent cube numbers for pictures? So the first cube number, so we write here, cube numbers, let me adjust. So you write here, cube numbers, pictorial representation. Pictorial representation. I'm going to show you how do we draw the pictorial representation of these cube numbers, 1, 8, 27, 64. 1, 8, 27, 64. Maybe you can proceed at your own time. How do we draw the pictorial representation of cube numbers? We use a paper we call isometric dot paper. To draw a picture for cube numbers, we use isometric dot paper for easy drawing. Now, everybody pay attention here. Let me start with the first cube number. The first cube number is 1. And it is represented by only 1 cube. So you draw 1 cube here on this paper, on this isometric dot paper. So you draw 1 cube like this. From one dot to the other, we count 1. From one dot to the next dot, we count 1. And we move only vertically and diagonally, no horizontal. So go this way. From one dot to the other, count one. So 1 vertical, 1 diagonal, 1 diagonal, 1 vertical, 1 dot, 1, 1. And then you close like this. You see that? This is representing the first cube number 1, which was obtained by taking 1 into 1 into 1. 1 into 1 into 1 gives you 1, which is the first cube number. And you have, how many cubes do you have? You have only 1 cube, which simply means 1 cube number. The next, you have 8. How was this 8 obtained? You do 2 into 2 into 2. You, on a picture, you're going to write from one dot to the other, you count 1. 1, 2 dots. You either go vertical and diagonal. Don't go horizontal. So diagonal, again 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. You have got a very big cube. Now divide it. You divide it this way, this way, this way, this way, this way, and that way. See that? So, how was this cube obtained? You did 1, 2. So you have 2 into 2 into 2. You have 2 into 2 into 2, and you have 8. Meaning, if you count here on this big cube, you will have 8 smaller cubes. Meaning, 1, 2, 3, 4, 5, 6, 7, 8 cubes. How about the next cube number, which is 27? This 27 was obtained by taking 3 into 3 into 3. Meaning, from one dot to the next, you count 3, 3, 3. So from here, 1, 2, 3, and then you do the same thing. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So you have 1, 2, 3. 1, 2, 3. 1, 2, 3. You have a very bigger cube this time, and then divide it. This way, that way, this way, and then go this way, that way, and then this way, and then this way, that way, this way. Now, what do you see? And how many small cubes can you see? We have 1, 2, 3. 1, 2, 3. 1, 2, 3. Meaning 3 into 3 into 3. You're going to have 27 small cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you keep counting, you will clearly see There are 27 small cubes on this picture. So you can now try for a 64. I will send this paper to you. You download it and then you try the next number, which will be 4 into 4 into 4, and this gives you 64, and this is the fourth cube number. But the first three cube numbers are 1, meaning 1 cube, 8, meaning 8 cubes, 27, meaning you have 27 small cubes. This is how to represent cube numbers by using a picture. So the sequence 1, 8, 27, 64 are called cube numbers. Why are they called cube numbers? They are called cube numbers because they represent the volume of a cube with side length n. What are those cubes? To clearly see them performing the art of cubes, you take this isometric dot paper and then you start displaying the number of cubes. Where the first cube number 1 will have 1 cube, the second cube number 8 will have 8 cubes, and the third cube number 27 will have 27 small cubes, and the fourth cube number 64 will have how many small cubes? There will be 64 cubes. Can you draw the picture for that? Try drawing the picture of it. All right? So try that and see how it's going to work. So now, next question, let us see. So you're going to draw a picture here. Now the next one is question number 9. Question number 9 says that a dash polygon is a shape with all sides and angles equal. So here you're going to write the word regular. A regular polygon is a shape with all sides and angles equal. Next question. The missing term in the sequence 3, 6, 9, dash 15 is, let us see, from 3 to 6, add 3, 6 to 9, add 3, 9 to a missing number, we're going to also add 3, so 9 plus 3, 12. Let us see, from 12 to 15, add 3. So, from 12 to 15, so 12 plus 3 is 15, which is this answer here. So, the missing number in this sequence is 12. Next question. Write the next two numbers of given sequence and name the sequence. 1, 7. 19, 37. We have discussed this and we said that these are hexagonal numbers. Hexagonal numbers. How do we get the next? Hex means 6. So from 1 to 7, they added 6. To get the next number from 7 to 19, take 6, add it to itself, you get 12. So here, from 7 to get the next number, you're going to take 7 plus 12, 19. To move from 19 to 37, take this 12, add 6. What do you get? 12 plus 6, 18. So add 18 here, meaning 19 plus 18, 37. To get the next number, take this 18, add 6, you're going to get 24. So from 37 to the next number, we'll add 24. 37 plus 24, 37 plus 24, 11, carry 1, 3 plus 2, 5, 61. So the next number here is 61. To move from 61 to the next number, take this 24, add to 6. What is 24 plus 6? So 24 plus 6. What do you have? 24 plus 6. You will have, that is 24 plus 6. 1 minute. 24 plus 6. That is 30. Now from 61 to the next, that means you're going to add 30 here. Now 61 plus 30, 61 plus 30, 191. That means the next number here will be 91. Okay? So you keep going. So this is a pattern. So the missing number here for hexagonal numbers will be 61, 91. And what type of sequence is this? That is a sequence of hexagonal numbers. Next question. 1, 4, 9, 16. This is what I told you. I will explain to you. 1 was obtained by taking 1 into 1 equals to 1. 4 was obtained by taking 2 into 2, and this equals to 4. 9 was obtained by taking 3 into 3, and that is 9. 16 was obtained by taking 4 into 4, and this is 16. Now see what is happening. We are taking a number multiplied by itself. 1 into 1, 1. We are taking a number 2 multiplied by itself. 2 into 2, 4. These numbers here, which are obtained by taking a number multiplied by itself, these numbers are known as square numbers. Square numbers are obtained by taking a number multiplied by itself. So quickly, the first number, 1 into 1, 1. The second number, 2 into 2, 4. The third number, 3 into 3, 9. The fourth number, 4 into 4, 16. To get the fifth number, you do 5 into 5, 25. So the missing number here is 25. One minute, give me a second. So, yes, put it here. All right, so now we have, to get the next number after 25, you will do 6 into 6, 36. So after 25, the next number is 36. And what type of sequence is this? This is the sequence of square numbers. Some other people call it a sequence of squares. All right, I think that helps. Next question. 2, 4, 6, 8. 2, 4, 6, 8. These are a set or a sequence of even numbers. How were they obtained? From 2 to 4, add 2. 4 to 6, add 2. 6 to 8, add 2. So we keep adding 2, get 10. Keep adding 2, get 12. So that is all about even numbers. The next one. 1, 3, 6, 10. What did we say? We said that is a set of triangular numbers. So you're going to write here, triangular numbers. We have discussed them in the previous video. So if you did not watch the previous video, go back and watch. triangular numbers. How was it obtained from one number to the next? Add 2, add 3, add 4, add 5, 15, add 6, 21. So the next numbers after 10 will be 15 and 21. So you have 15, 21, and that is all. The next question. Which sequence do you get when you start adding counting numbers up and down? These are counting numbers. So, counting numbers, when you add them up and down, which sequence do you get? Arrange these counting numbers from down. 1, 2, 3, 4, 5, 6, maybe, and so on. And then we're going to add these numbers going up and down. Starting with 1, you're going to have 1, put a comma. To get the next number, do 1 plus 2, reverse. So you have 1 plus 2, reverse, plus 1. To get the next number, again, you have 1 plus 2 plus 3, reverse, plus 2, plus 1. So you have 1 plus 2 plus 3, reverse, plus 2, plus 1. Again, to get the next number, do 1 plus 2 plus 3 plus 4, reverse, plus 3 plus 2 plus 1. So you will have 1 plus 2 plus 3 plus 4, then reverse, plus 3 plus 2 plus 1. We can stop here. So the first number was 1. Calculate this. 1 plus 2 plus 1, that is 3 plus 1, 4. What is this? 1 plus 2, 3 plus 3, 6, 8, 9. What is this? 1 plus 2, 3 plus 3, 6 plus 4, 10 plus 3, 13 plus 2, 15 plus 1, 16. And so on and so forth. Now the question is, what is this new sequence you get? We call this is a new sequence which shows a sequence of square numbers. So you say this new sequence is known as a sequence of square numbers. A sequence of square numbers, or some other people call it squares, like this, squares. All right? So I hope that is clear and it helps. So you can try to go through this and see what do you remember. Okay? So the next question. Complete the following number sequence. Complete the following number sequence. 1 plus 3 plus 5 plus a missing number, then plus 9 plus 11. What type of numbers is this? These are odd numbers. Meaning, from 1 to 3, add 2, add 2. So add 2 here, get the next number will be 7. Add 2, 9, add 2, 11. Okay? So the missing number here is 7. And what is 1 plus 3 plus 5 plus 7 plus 9 plus 11? What is it equal to? That will be equal to 36. You can try to help me check that. Look at this. 1 plus a missing number plus 3 plus 4 reverse. Look, 1 plus a missing number plus 3 plus 4 reverse plus 3 plus 2 plus 1. So the missing number here is 2. 1 plus 2 plus 3 plus 4 reverse plus 3 plus 2 plus 1. And what is this number equal to? If you take 1 plus 2 plus 3 plus 4 plus 3 plus 2 plus 1, the answer will be equal to 16. Next. One plus 2 plus 3 plus a missing number plus 5 plus 6 plus a missing number plus 8 plus 9 plus sorry. So this is sorry for that. This is a series of adding counting numbers. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15. If you add all these numbers, what do you get? You're going to get 100. Okay? So you can try to check that. All right? Next question. State whether the following statements are true or false. The sequence 1, 4, 9, 16, 25. We have seen this sequence. This is a sequence of square numbers. Square numbers. That is a sequence of square numbers. 1, 4, 9, 16, 25. We have seen them. Is an example of cube number? The answer is false. So that is false. A regular pentagon, anything regular means it has equal sides and equal angles. So any shape which is regular, it means equal sides, equal angles. So when they say a regular pentagon has equal sides but different angles, that sentence is also false. Because the question says, state whether the following statements are true or false. The next question. The sequence of odd numbers. Odd numbers. What are the odd numbers? You have to know them. 1, 3, 5, 7. So it's like adding 2, adding 2, adding 2, 9, 11, 13. These are odd numbers. You have to know them. Now the sequence of odd numbers start with 1, 3, 5, 7. That is true. That is true. The next question. The next question. A shape sequence starting with a square and adding one side each time would form polygons with increasing number of sides. It is true. A square has 4 sides. If we add one more side, we get a pentagon, which has 5 sides. Next, a hexagon, 6 sides, and so on. So the sequence is a square. So the sequence is starting with a square. When you add one side to the square, you get a pentagon. Add one side to a pentagon, you get a hexagon. Add one side to a hexagon, you get a heptagon. Add one side to heptagon, you get octagon. And the sequence continues. So each step, when you add one side, it forms polygons with an increasing number of sides. So this sentence is true. The next question. The number 36 can be both a square number and a triangular number. This sentence is true. We have discussed this in the previous video. So if you did not watch video part 1, go back and watch on patterns in mathematics. So the number 36 can be both a square number and a triangular number. So that is true, and we have seen it. Now, let us see case-based questions. A honeycomb follows hexagonal pattern. Do you remember hexagonal numbers? Hexagonal numbers starts with 1, then 7, then 19, then 37, then 61, and so on. We have discussed about hexagonal numbers in video part 1. So you did not watch that, go back. You're going to see and you're going to try to memorize what are hexagonal numbers, and you have to remember them. So this is the first hexagonal number, second, third, fourth, fifth. So a honeycomb follows a hexagonal pattern. If the first row has 1 cell, the second 7, and the third 19, how many will be in the fourth? The answer will be 37 cells will be there. Okay, so 37 cells. The next question. A staircase follows a pattern. The first step has 2 tiles, the second has 4, the third has 6. What pattern of numbers is this? These are even numbers. These are even numbers. Now, the first even number is 2, second is 4, third is 6. Now, figuring out the fourth, fifth, sixth, seventh, eighth, ninth. Stop there. So 2, 4, 6, 8, 10, 12, 14, 16. Guess what? This will be 2, 4, 6, 8, 10, 12, 14, 16, 18. So a staircase follows a pattern. The first step is 2 tiles. The second is 4. Third, 6. How many tiles will be there on the 9th? On the 9th, we have 18 tiles. So you're going to write here 18 tiles. That's all. 18 tiles. All right? So now, next question is C. Next question is part C. Let me see. All right, so let us continue. Ram and Devi are playing with square counters. Ram arranges his counters as follows. You have here, how many counters are there? Only 1. How many counters are there? 3 counters. How many counters are there? 1, 2, 3, 4, 5, 6. Now, that is all about Ram. Devi arranges her counters as follows. How many counters are there? 1. How many counters are there? 1, 2, 3, 4. How many counters are there? 1, 2, 3, 1, 2, 3, 3 into 3, 9. Okay, so what patterns do you see? 1, 3, 6. Can you tell what pattern is this? Look at the shape. Guess what pattern is this? If you guessed a pattern of triangular numbers, then you got it correct. That is a pattern of triangular numbers. How about this pattern? 1, 4, 9. This is a pattern of square numbers. Or some other people call it a pattern of squares. A pattern of squares. Right? So now let us see the questions. One of their friends says that these are showing the number of patterns. Based on above information, answer the following questions. The first question, what are the number patterns they are showing? So like as you said, RAM is showing a pattern of triangular numbers. So RAM is showing a pattern of triangular numbers. So you're going to say RAM is showing a pattern of triangular numbers. And you're going to say Devi is showing a pattern of square numbers. Or in short, you can say squares. Right? Now, the next question. If Ram's arrangement is representing the triangular numbers, like how we said, then what will be his next two arrangement if he follows the same pattern? Simple. Look at the foundation here. You have only one square. Look at the foundation here. 2 squares and 1 on top. Look at the foundation here. 3 squares. So the next number will have 3 squares in the foundation. So go ahead and make 1, 2, 3. So make 4. Here. Make 4. 1, these are 2, these are 3, 1, 2, 3, 4. And then take 1, put it just above here. And take another one, put it here. Take another one, put it here. See that? And take another one, put it here. Take another one, put it here. See that? And take another one, put it on top here. What do you have? Let us see. Here you had 1, 1, 2, 3. 1, 2, 3, 4, 5, 6. What do we have here? 1, 2, 3, 4, 5, 6. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What are these? These are triangular numbers. 1, 3, 6, 10. These are triangular numbers. Now, because they need to get the next two arrangement, so let us keep one more. So look at the foundation. 1, the foundation has 2, the foundation has 3, the foundation has 4. So you're going to make a foundation here. Make a foundation which will have how many? 1, 2, 3, 4. So you're going to have 5. You're going to have 5. So take, that is 1, 2, 3, 4, 5. See that? And then take 1, put it here, 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 here. These are like building blocks. And then 1 here, another one here. And put this one here. Now, you're done. These are building blocks. So let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What are these? 1, 3, 6, 10, 15. What are these? What are these numbers? These are triangular numbers. Okay? Now next. What is Devi's next arrangement with counters if she follows the same pattern? Simple. What is this? These are square numbers, meaning you have only one box, 1, 2, 3, 4. You have only 4 squares, 1, 2, 3, 1, 2, 3. You will have 9 squares. Now, to draw what we call square numbers, because this is 1, 1 into 1, this is 1 into 1, 1. This is 2 into 2, 4. 1, 2, 1, 2. 2 into 2, 4. 1, 2, 3, 1, 2, 3. 3 into 3, 9. To get the next, guess what? I will take 4 into 4. I will get 16. To get the next one, 5 into 5. I'll get 25. How do we draw these squares or these square numbers on a pictorial representation? It's simple. To draw square numbers clearly and neatly, we use a graph paper. So I'm going to do 4 into 4 equal to 16 on a graph paper. So this is a graph paper. So we're going to do 4 into 4. Meaning, from here, we need to get 4 into 4. So meaning count boxes. 1, 2, 3, 4 boxes. Then you go again. 1, 2, 3. Let me repeat that. Let me repeat that. Count 4 boxes. 1, 2, 3, 4. Then you have 1, 2, 3, 4. Then you have 1, 2, 3, 4. Then you have 1, 2, 3, 4. And then cut this into 1, 2, 3, 4. Then you have 1, 2, 3, 4. So what do you have here? We have 1, 2, 3. We have 1, 2, 3, 4. So 4. Going down. And you have 1, 2, 3, 4. You have 4 going to your right. So what do you have in total? 4 into 4 equal to 16. See that? 16 is one of the square numbers. So which will come here? This diagram will be drawn here. How about 5 into 5? Quickly. 5 into 5 on a graph paper is easy. 5 into 5, so you're going to have 1, 2, 3, 4, 5. See that? 1, 2, 3, 4, 5. And then you have 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. And then you have 1, 2, 3, 4, 5. And they cut it there like this. Just cut to get small squares. Cut like this. What do you get? Let us see. Going down, how many boxes are there? Or how many squares are there? 1, 2, 3, 4, 5. Going to the right, how many boxes do you have? 1, 2, 3, 4, 5. What do you have? 5 into 5. 5 into 5 gives you another square number, 25. All right? So that's all about Devi next arrangement, which will be drawn on a graph paper, and that represents a pattern of square numbers. Okay? I think that helps. Let's go to the last question. Do you have the last question? Let me see. Okay. Is there anything I skipped? Let me go back. I hope we did not skip anything. Okay, we did not skip anything. We did not skip anything. Here we did not skip anything. Here the sequence why they called cube numbers and pictorial representation. So we did everything, right, on this worksheet. So that's all. We are done with this worksheet on pattern in mathematics. So stay tuned for the next worksheets. Okay, so I'll be uploading the videos one chapter after the other. So stay tuned. For now, let me stop here. Bye-bye.